Hello everyone, welcome to Dnyanadeep. In this UPSC Explained series, we are going to discuss this week's some important news development. So here I am with this topic, that is giant ozone hole. So recently a group of scientists have discovered a gigantic ozone hole in the stratosphere of Antarctic. Now it has been observed that this ozone hole is amongst the largest ozone hole which has developed in last few years. By and large, our understanding was, with the efforts we have taken at global level to cut down the use of ozone depleting substances, that ozone layer was repairing or healing. But suddenly this development has come and it has been surprising or shocking in many ways. So we'll understand step by step what this ozone is in the atmosphere, what do we mean when we say ozone hole, what are the various keywords which are associated with it, and what is the latest development which is concerning us all. Now first and foremost, let us try to understand where this ozone is. Now we all know there are layers of atmosphere, that is troposphere, stratosphere, mesosphere, thermosphere, and so on and so forth. So in the stratosphere, we find that there is a layer of a gas, that is ozone. And this ozone layer which is present in the stratosphere, it protects us from the harmful UV rays which are coming from the sun rays. So what it does, it will absorb ultraviolet rays which are coming from the sunlight or the sun, and as it is absorbed in the ozone layer itself, in the lower parts of the atmosphere there is lesser amount of ultraviolet rays. So that is how this ozone layer acts as a barrier and protects the biosphere of the earth, and that is why we also call this particular ozone layer as a good ozone. Now what happened in last 100 years or after industrial revolution, a lot of man-made substances were being used, substances such as chlorofluorocarbons, that is nothing but halogenated compounds we call them. And these halogenated compounds which were used in air conditioners, refrigerators, they escaped into the atmosphere through various human processes, and somehow these substances land up in the stratosphere. Now ozone otherwise is very stable. There is hardly any possibility that we can break ozone so easily. But what happens with the presence of these chlorofluorocarbons or halogenated compounds? During a specific condition, these CFCs lead to the breaking of ozone, that is O3. It converts it into oxygen, and that is how the layer of stratosphere or the layer of ozone which is present in the stratosphere, it is getting destructed. So we'll understand how this ozone layer is getting destructed or what has been the history. So this is the graph of the ozone layer which is present in the stratosphere. Typically we have measured the presence of ozone over the Antarctic, and if you see what has happened over the past few decades, so we find that during 1960s, this particular was the level of ozone. Now this is the unit, 300 is the number. One word which we need to understand here is, that is Dobson unit. Fine, remember this particular word. This can be your prelims question, that what Dobson unit does. So Dobson unit is nothing but it is the unit we may use to measure the concentration of ozone in the stratosphere. Now the concentration of ozone in the stratosphere, it went on declining over the period of years. Now when we approached around 1980, suddenly it was discovered that there is a lot of depletion or lot of destruction of ozone layer is taking place in the stratosphere. And somewhere then we started to think about this particular issue, because we know ozone layer is very important to protect our biosphere. So then global community came together and they decided to protect this ozone layer. And as a result of this, we come to a protocol or a convention called as Montreal Protocol. Fine. And in the same way, there is one more initiative which is discussed in terms of ozone layer protection, that is Vienna Convention. So in some other sessions, we will discuss what this Montreal Protocol suggested or this Vienna Conference suggested. Now, what our objective here today is, we are going to understand what are the recent development. So, I am simply giving you a brief idea what happened post 1970s. We find that there is a significant drop in the stratospheric ozone, and somewhere then in 1980s or early 1990s, we as a global community come together, implement a provision called as Montreal Protocol. Now, the fundamental provision of the Montreal Protocol was to eliminate the use of chlorofluorocarbon, that is CFCs, right? So these are the typical compounds which are used in air conditioners and refrigeration systems. Some industrial processes also involve the emission of chlorofluorocarbons or other halogenated compounds. Now, we decided to eliminate the use. We replaced CFCs with some other compounds, that is HFCs and all, and that is the effort which led to the saving of the ozone layer. And you can very well see, as we implemented Montreal Protocol or the provisions of Montreal Protocol, the ozone layer, which was very significantly destroyed over the Antarctic, now it started to heal itself, and somewhere when we are in 1920s, we see that it is getting healed, and after 2050 we will have a good proportion of ozone once again in the stratosphere. Now, this is something which is going to happen over the period of year as the provisions of Montreal Protocols are being implemented. So that has been the very positive development over the years. Montreal Protocol is also considered as one of the most successful treaty or successful initiative in the history of environment, right? So that is one overview of the ozone layer depletion. Now, there are some keywords which are going to get associated with the ozone layer depletion. CFCs, this is something I have already answered. Now, my interest is in polar stratospheric cloud. Now, when I say polar stratospheric cloud, I told you, or I was time and again saying that there is a ozone hole destruction or ozone hole over the Antarctic. Now, when I say time and again that ozone hole is over the Antarctic, does that mean there is no ozone hole or no depletion of ozone all over the earth or everywhere in the stratosphere? So we'll go to this particular fundamental part. So just understand one thing, that whatever chlorofluorocarbon is getting released into the atmosphere, it is reaching everywhere in the stratosphere. But most of the ozone depletion is found over the Antarctic, that too during the winter season, because there is a development of certain conditions. Now, I earlier told you that it is very difficult to break ozone, but there are certain conditions under which this ozone can be broken. So what happens over the southern hemisphere or south pole, that is typically over Antarctic, during the winter temperatures are very, very low. If we go to the stratosphere of the Antarctic, there again we find development of one cloud, that is polar stratospheric cloud. These are only formed during winter. Now, in this particular condition, temperature is in the range of some -70 or 80 degrees Celsius, that is during the winter. And ultimate result of this particular condition, it acts as a catalyst and it results into breaking of ozone with the help of chlorofluorocarbon. So you can see whatever halogenated compounds are present in the stratosphere over the Antarctic, now they will react with ozone and result into formation of oxygen. So ozone here is continuously getting converted into oxygen. So that is something which we find happening in the stratosphere of the Antarctic. Now the same process also happens everywhere in the stratosphere, but for this process, for this chemical reaction to take place, what we need very low temperatures, and these low temperatures are profoundly visible or profoundly found only over the Antarctic. So there is depletion of ozone everywhere in the stratosphere, but it is not that significant or it is not that high. When it comes to Antarctic, as temperatures over Antarctic are fairly low, it prompts more destruction of ozone, and that is why a very big hole is formed over the Antarctic in stratosphere and a lot of ozone has depleted. So that is one overview when we talk about polar stratospheric cloud or CFC, or how this ozone gets destructed. There is something called as humidity technique. It is nothing but a technique which is used to measure the concentration of ozone in the stratosphere. Dobson unit is nothing but the unit which is used to measure the concentration of ozone in the stratosphere. Montreal Protocol is something I have already given you. Kigali Amendment is something you need to answer in the comment box. Once you are done with watching this video, do answer in the comment box what this Kigali Amendment is and what was the purpose of bringing in Kigali Amendment. Also mention the significance of Kigali Amendment for India, because it has been in discussion from India's perspective as well. Fine. So these are some keywords I have given you regarding the ozone layer depletion. Now we will get back to the latest issue, that is a giant ozone hole has formed over the Antarctic. Now these are some observations which have been given by European Space Agency. So European Space Agency is saying that there is 26 million square kilometer of ozone hole, which is a size of Brazil, is formed over Antarctic. We have found that it was repairing. Stratospheric ozone was healing, but suddenly there is a giant hole. Now in this particular para there is a information regarding what this ozone is, where this ozone hole forms. We have to now address why there is this latest development. Despite use of HFCs, which are not going to affect ozone layer, and CFCs have almost been now eliminated in human use, we still found that there is a formation of ozone hole. The fundamental reason for this formation is being given that there is a climate change which is happening, and this climate change is prompting the more destruction of ozone hole. So typically over Antarctic, what we see that there are certain conditions which are getting developed, which are unique to the Antarctic only. So there is lower temperature, some pressure formation is also there, wind speed and direction which prevail over this continent, and this will result into more CFCs being present in the stratosphere of the Antarctic. Now what has happened, that we find that there are certain winds which are blowing in the region of Antarctic, and they have created a sort of mini climate over this particular area, and that is the reason where we find that more and more ozone is getting depleted. So there are some other reasons also. One typical reason which has been provided is that of volcanic eruptions from Tonga, and the volcanic eruptions from Tonga has resulted into a lot of water vapor getting released into the atmosphere. As a lot of water vapor gets released into the atmosphere, it will reach out up to the stratosphere. See, otherwise there is no water vapor in the stratosphere, but whenever there is a volcanic activity, this volcanic activity, whatever water vapor it releases and whatever other chemical it releases, it directly can be pushed into the stratosphere, because that volcanic activity, typically when we talk about Tonga eruption of 2022, it threw a lot of volcanic material directly into the stratosphere, and somehow all this material has now accumulated in the Antarctic region or the stratosphere of the Antarctic, and this is something which is resulting into the depletion of ozone layer in the stratosphere. Now there are some other factors also, such as wildfires. A lot of times we have found that whenever the frequency of wildfire all over the world increases, that results into again release of certain chemicals into the atmosphere, somehow reaching the stratosphere and resulting into depletion of ozone layer over the Antarctic. This effect is again very profound in the Antarctic region only, right? So these are some important facts which we need to keep in mind. Apart from chlorofluorocarbons, there are some other phenomena. They are also responsible for the depletion of ozone, and somewhere here you may find the question again, right? So UPSC may give you a prelims type question in which it will ask you which of the following are reasons for the depletion of ozone, and in that CFC is definitely there, but then again we can have options such as volcanic eruption, forest fires, so on and so forth, right? So that was the development which took place recently. We will see you again with similar type of developments, and we will find that what type of question can be asked in the particular context. So see you again. Thank you.